a little bit smaller than Earth, and this is done for a few very good reasons. Firstly, it takes about 12 minutes to get to low Earth orbit in real life. And if you had to spend 12 minutes just getting into orbit before you could actually do anything exciting, you'd get quite fed up fairly quickly. Whereas in Kerbal system, depending on how well you've over-engineered your rocket, you can do it normally in about 6 minutes. The other good reason for having it at a smaller scale is decimal precision and memory usage. If you have to model a solar system that's as big as ours, the numbers are astronomical, and you know, they take up quite a bit of space. There are mods if you've got a very hectic gaming rig and you want to run a real solar system. You can go ahead and download that. But for the casual gamer like me, filthy casual, it's pretty straightforward. The planet Kerbin itself is inhabited by the Kerbals. So the Kerbals fulfill all of the jobs that are required around the Space Center. How they ever managed to evolve into having a space center is a matter for debate, but there you go. The three most famous Kerbals, the first Kerbals that were able to get into space are Bill, Jebediah, and Bob. And in a recent patch, they added Valentina, the first female Kerbal. She's a pilot. And originally, the game designers had wanted Kerbals to be genderless, but you know, if you looked at them previously, they're quite distinctly male. And hopefully in a future patch, they'll add the other 49 or so genders.
But now, yeah, Valentina can fly to her death just like Jeb.
Yes, equal opportunity.
Yes.
So you can see there, again, the scale between normal astronauts and Kerbals in the top right. Kerbals themselves can be quite suicidal. And to give you a bit more of a insight into how they actually function as a society, we've got a little video.
That is the correct spelling of moon, by the way.
So this is recovered footage from the first Lunar mission. Sadly, the mission had a bit of a tragic end, but we're hoping for a rescue mission sometime in the future. The game itself has two primary modes. You've got the career mode, which is more of a role-playing game type thing where you progress and you build, start from a very small space center and build out your space program, and Sandbox Mode, where you get to build some really cool stuff without the constraints of resources. So the way you basically progress through the career mode is through contracts. And they basically allow you to take your space center, and this is the first level one with a dirt runway, which is completely uneven and quite hard to take off on.
Also, the launch pad is mostly just a pile of dirt as well.
Yeah, it's technically just a big pile of dirt. You can then upgrade your buildings, and each of the buildings itself is upgraded independently, so there's quite a lot of progression and a lot of decisions that you have to make. Ultimately, you want to get to level 3 of all the buildings, where you can do all of the cool stuff and you've unlocked all of the parts. And then oftentimes what happens is your space center ends up looking like that when you fly rockets into it by mistake. So you can primarily get your contracts from the contract screen, you build up reputation, and you can actually see what each mission is actually going to entail and what rewards you'll get from completing it. You can also use the astronaut complex to recruit willing Kerbals to die in the name of science. And yeah, So here we've got a quick screen, and the HDMI cable's a little bit wonky. We've got a quick video of what the gameplay looks like. You've got a whole bunch of parts you can choose from in different categories. You can launch your vessel, which will take it out to the launch pad. And then you can fly that and have screwed up your staging. But, you know, these things happen, and it's all about taking a negative, turning it into a positive. This footage has been, most of the footage has actually been sped up due to time constraints. But you can see here, you can take a negative mission and turn it into positive. Flags are a big thing in Kerbal society. So, you know, planting them in all sorts of places is great.
And if you've upgraded your astronaut complex, you could also take a soil sample now, as useful as that would be on the launch pad. But
and those tasty, those soil samples leads to the very tasty science. It's a big part of Kerbal culture that Minmus, one of the moons, is actually made out of pudding. And you can see some footage from that mission.
I can confirm that it is. I've been there.
So once you've taken that science, you can use that as the alternative resource to unlock the tech tree and get bigger and better parts. If you look,
to the more eagle-eyed, you'll notice there is a nuclear symbol there in the top right. Yes, the game gives you nukes. Not missiles, but rockets. But it's still cool. It's still cool.
And if you're into modding, you can get actual nukes, and you can add those to your game. Then we come to the Sandbox Mode. Sandbox Mode is really cool because you can build whatever you want, whether it's a space bar or having pirate ship battles in the middle of low Earth orbit, or an elephant. You know, there's nothing saying that you have to actually, just because it's got space in the name doesn't mean you have to go to space. If you are a fan of Pacific Rim, you know, you can recreate the Gypsy Danger and implement that in the game using many flat panels, and that poor Cobol is not going to space today.
I would say 90% of all launches don't get to space.
Yeah. It's a little bit less than the NASA record, fractionally, but there you go. The game itself was actually started by Squad, which is a Mexican advertising agency. They made some advertising games for some of their clients, and one of their developers was pretty into space. So he started up this game and started building a community around it. So it's built from the ground up to be moddable. And the game itself is written in .NET, C#, Mono, which is why it's running now on a Linux PC, although I did find a memory leak. I'm not sure if it's Linux specific, but there you go. And most recently, it's been ported to the console. So you can get this on your Xbox or PlayStation if that's your thing. So when Jake and I started, we really wanted to do that. You know, we wanted to have a way of controlling the game that wasn't just the keyboard and the mouse. We wanted all sorts of doohickeys, thingamabobs, switches, multifunction displays, and all of that. And we looked at this problem and we said, okay, well, you know, there's a lot of information out there how to build an Arduino controller or a Raspberry Pi controller, so that part's pretty well solved. How do we actually get that input from the controller and send it into the game? So we did a bit of research, and there's a few options. The first one we took a look at is Kerbal Operating System, KOS. So this is a programming language that is based on Kerbal culture. So it's very simplistic, very straightforward, like lock position up. You know, so it can be pretty expressive and declarative, but because we're insane, we wanted to do it in JavaScript because, you know, JavaScript's great with maths, so we figured we'll do that. So we took a look at some of the other options. The one we ended up settling on is called KRPC, Kerbal Remote Procedure Call. So this is a mod. It sits in your folder. It's written in .NET, and it exposes a server that listens for incoming connections, and it basically then allows you to transmit those connections to the game itself.
Those are TCP/IP or WebSockets connections.
Exactly. Unfortunately, there wasn't a node.js or JavaScript client for it, so like any sane individual, we went ahead and we wrote one. This is a bit of an old screenshot. It's now on version 4, and it's been quite successful. We've got quite a few downloads per day now, and a lot of people are using it because, you know, everybody's mad about JavaScript at the moment. It's the hot thing, so people want to do that.
We even got forked.
Yeah, that was quite an experience. So the game itself, you know, you've got your server, which is running the .NET code, and then you've got your client, and it uses WebSockets to do TCP connections. The cool thing is to do the communication back and forth, instead of XML or JSON, we use Google protobufs. Now, that's done for quite a few reasons, primarily for performance. So it's a binary format, and it allows you to send data back and forth from the server and the client in much smaller packets at much higher rates. And that's quite important if you want to real-time control a spaceship into orbit. So if you look at the pretty graphs, you can see that Google protobufs are much better. And yeah, so we're both pretty big fans of SpaceX.
Woo!
So we wanted to sort of see if we could model their progression in our progression. So for those of you who might not be too familiar with it, SpaceX started with a joint launch. They then moved on to the Falcon 1, which was going to be the make or break of the actual company. If that launch blew up or went badly, the SpaceX would not be here today. That was the last dollars of the company went into that. But luckily it was successful. They then went on to the Falcon 9, eventually launching the Dragon capsule to resupply the ISS in low Earth orbit, and then to the Grasshopper launcher. Then they did a soft landing in the water, return to landing site launch, and eventually a landing on the barge. Cool, so this is Gwynne Shotwell. She's actually the Chief Operating Officer of SpaceX, and she's primarily responsible for a lot of the success. Elon might be the brains behind the ideas, but she's the one who actually has to go ahead and implement all of his crazy stuff.
He's the poster boy.
He is the poster boy.
Yeah.
So for those of you who might not be familiar with him, he started with Zip2 as his first company. He developed that, sold it, went and did a joint, established PayPal as a joint company, eventually sold that, and then founded SpaceX with that money, then took some money out of there to found Tesla, which then ended up buying SolarCity, or the company that became SolarCity. They've got OpenAI. If you follow Elon on Twitter, you'll know that he believes that AI is one of the things that's one of the potentially biggest threats to humanity is AI. So it's all about establishing AI in a safe way. And then most recently, they've started The Boring Company, which is all about distributing flamethrowers to the rest of the world. Actually, it's about boring holes into the Earth so that they can build a Hyperloop system.
Get it? Boring?
So Elon Musk is quite an ambitious character. He's known for doing the things that are impossible, and he gives me hope that I'll be able to regrow my hair one day. He's also a bit of a character, and a lot of people find him a bit strange. And if you've ever seen him doing a public speaking engagement, he's not the best public speaker, but he speaks genuinely, and it's from the heart. So for those of you who are at JSNSA, you might have seen our Grasshopper Mission. This is highly sped up footage, which again is quite jittery, sorry for that, of the Grasshopper Mission. Basically, it was a tech demo to prove that they could launch and land a rocket. So you'll see it flies up to about 300 and something meters. This is just one of the smaller tests. It did eventually go up to, I think, about 700 odd, and then makes a precision landing back on the pad. So to recreate this, what we did is we did a manual control. This is me recording, trying to hover manually with the little puddle jumper craft that I made, which is available on GitHub with the code for this. Then I tried to use equations of motion, but you basically always end up coming with either the throttle needs to be at 100% or 0%. And this is quite a common problem in engineering, and it's primarily solved using the PID algorithm, which is proportional integral derivative. And if you went to engineering, you study engineering at varsity or that, you might actually know what that means, but I don't. So I just plugged in a whole bunch of random numbers until it actually
I did study that stuff. I have no idea.
So there you go. I don't feel too bad. So you'll see here, this is a bit of a recording. It's very choppy.
Videos are not running well.
No,
This did not happen in our tech rehearsal.
Yeah, the VGA adapter seems to have worked a bit better, but there you go. So you'll see that you'll just trust us. Basically, it was pretty successful, and there were some explosions. So yeah, one of SpaceX's main goals is to make humans a multiplanetary species. And that's because you never know what's going to happen to Earth. A meteor could come around and kill all known life. It's happened before with the dinosaurs. with the current political situation, there could be a nuclear war, and then there's no more humans left. So we're like, what do? We need to move to Mars. So originally what they thought was the Falcon Heavy was going to be the bulk lifter for this job. It's since been replaced by the new rocket, which I've gone blank on because of nerves, but there you go.
Falcon Heavy.
So for those of you who might have missed the Falcon Heavy launch a little bit earlier this year, here's some of the footage, highly sped up, and it's after the launch where the 2 side boosters did a synchronous landing back on the pad. So in the top left-hand corner, you've got the view from one of the cores. Top right, you can see an external view from the ground, and then in the bottom left and right is the footage from the side boosters themselves.
If you're nerds like Ryan and I are, we were both glued to this live. I cried during this moment here.
I also cried.
We both cried.
Yeah, not afraid to admit it.
Yeah.
Totally.
It was beautiful. Oh, look at it. Come on. Yes.
So one of the most beautiful moments in space exploration, in my opinion.
During our lifetimes, at least.
Definitely.
I'm sure the moon landing thing was pretty cool.
Yeah. So the rest of that mission was basically, it was a tech demo to show that the Falcon Heavy can actually launch things. And what Elon did is he launched his cherry red Tesla. Now, we took a look at this mission, and a cherry red Tesla is a pretty awesome car. I'd love to have one.
It seems like he missed a step. Like he could have sent something cooler than that.
So we figured, there was a way to do this, but also get a little bit more value as well. So we decided to plot our own mission. And to do this, we need to know a little bit more about orbital mechanics and that sort of thing. So we had to recruit some scientist people and get a bit of a basic understanding of the principles behind launching rockets. So here you've got a space ship with the various directions that it can go in. I've got some videos that illustrate this a little bit better. So you can see here this rocket is pitching forward. Then we've got this rocket is going into a roll. And this rocket is yawing off to the left. So that's sort of your directions that you're going in. You've got go faster with thrust, and then you've got your compass directions. So starting at 0, going all the way to 360, which is back at 0. Now that we know all of these things, we can just simply take the variables and plug them into the Tsaikovsky rocket equation to figure out how to get to space. And that's what that equation looks like, so we decided not to use that. Maths, not even once.
Nope, no maths.
Sorry for the younger audience members. Cool.
So now we're going to go into a game demo. And
Cool.
in-game, hopefully it won't jitter like the videos were. That would be awful.
Yes, that would be very awful.
Sorry, Ryan's got Linux and it's weird.
Cool.
Is it working?
I think I might have bumped the cable. Yeah.
White screen of doom.
White screen. Hold this for a sec.
Everything is falling apart. Here you go.
Cool. All right, so here's the source code for our demo. I'm just going to run this from WebStorm. We'll go back into the game quick, and you'll see at the bottom there's the output for what the script's actually doing. So here's our rocket on the pad, and you can see there's a display at the top there. That's going to read out all the things that are happening. So this is our recreation of the Falcon Heavy mission, and let me just change this so you can actually see what's going on. Cool. So for time reasons, I'm just going to speed up. You'll see I've written how close we are to the next event in the bottom, which helps with time warping.
Yeah, you can't time warp while trying to feed the game commands. Things go wonky.
Yeah, so I learned when putting in delays, make sure the delays are game time and not real life time, because sadness ensues otherwise. So we're just accelerating through a gravity turn at the moment. The rocket is going to at 30,000 meters. We'll do the separation, so the boosters will separate.
You'll also notice we're going to the east, because that is the direction the planet spins in. Helps us with efficiency of fuel.
Exactly. So you can actually save around about 120 meters per second, if I'm not mistaken, of delta V in-game by taking off and going east instead of west, so with the rotation of the planet. And we'll see this a little bit later as well. So here we have the central core. The boosters have separated. This will then separate. The second stage will then take the payload into orbit. So here we can see the second stage is separated, the interstage fairing is safe, and we've got 11 seconds until the next event and the big reveal.
Fill the time. I got nothing.
We got nothing.
I got nothing.
So now the payload fairings are going to separate and reveal our DeLorean, heavily modified DeLorean. So, we figured one of the missions fairly recently to Mars was to figure out why did Mars lose its atmosphere? What better way to figure that out than being able to actually go back in time? And see, the problem with the DeLorean is it goes back in time, but in the same place. So we actually have to send the DeLorean to Mars so that we can actually go ahead and then go back in time in space, and then we can observe from orbit.
Come on, it's genius, really.
It's logical, really. Cool, so I'm just going to speed up here and get us into a circular orbit. Oh, see now, the problem with accelerating past the point at which your burn should have started is that the script doesn't take that into account. So I'm going to have to manually intervene when this burn actually finishes. But if I'd been patient and waited, it would circularize the burn quite nicely and automatically cut off the script. And if I had planned better, I would have had more time to make the script do that automatically if I screwed up in the demo. But here we are. So some manual intervention will be required. We'll just accelerate here, and you can see the blue line, which is our orbit line, is going to get sort of circular. And then theoretically,
here comes the periapsis.
The script would stop it, but I manually did that. And then you can manually separate out your car, fire the Separatrons, or take the second stage to Mars, separate from that, and deploy all the solar panels. Because why not? You need solar panels. And then you can control from here. And because I put ion engines on our modified DeLorean, you can drive for days. Cool. Thank you very much.
No, we're not done. We're not done. Wait. Sorry, we still got a lot, actually.
Yeah, we still got tons. That's just the first part of the demo. If there's time, I'll come back and show the synchronized landing. I just don't want to eat into too much of our other time. So let's just resume from current slide, which was not the current slide, but there you go. Cool, so mission's accomplished.
Right, that brings me into the picture. We still had to build a controller. It's great, we can now talk to the game and all that. But yeah, we still had our initial goal to try and fly into space with electronics and JavaScript. So what we're looking at here is Johnny 5. For those of you who were around in the 80s, he was a cool robot in a movie called Short Circuit, but you don't really need to know about that. Johnny 5 is also a very cool JavaScript robotics programming framework, as the slide suggests. And it's awesome, and hooray for Johnny 5, because it made my life a lot easier. So this is a basic Hello World, the equivalent of Hello World in electronics, which is to get the LED to flash, right? Just make the LED flash. And as you can see, it's JavaScript. Not many lines of code there, and it's stupidly easy, and you can see my cool animated thing. We now have a blinking LED. Getting an LCD to work, just as easy. You just pass it some config things about pins and rows and stuff, and then you say, hey, print. And there we go. So this was my first and only attempt to sort of do a wiring diagram for this thing, as you'll see why just now. It turns out this program I was using, Fritzing, sort of fell apart when I added all the various switches and things and the spaghetti nightmare that this thing has become.
You would have thought that would have been a sign.
Yes. Yeah, and this was our first prototype. We called it the Mark I. It was very cool. I can highly recommend working like this. This was a cardboard box. In fact, it is the cardboard box that the Arduino arrived in. And I decided to build the controller into it. It was very cool. I could just sort of open up the flap, and I had my breadboard under there, and the Arduino, I could just pull cables out like crazy. And it was very fun to work with, but it was not particularly easy to travel with or to show people. And yeah, we couldn't have showed it at a place like DevConf in that kind of state. So we decided we needed to do something a bit more.
It was also a little bit fragile.
Yes, it was incredibly fragile. Hey, the Mark II is also fragile. Anyway, so we had to design something. This is what we sort of came up with. At the top there, you got the 9 buttons, which are your action groups for those who've played the game. Actions are just various things you can toggle, like as you saw Ryan doing, extending solar panels, turning on lights, all that kind of thing. We've got a throttle control there, which is just a potentiometer. We've got a variety of toggle switches for turning things on and off. Lights and RCS and SAS, those are game terms. I don't think I need to, we don't have time to explain them, so just accept that they do things in the game. Then we've got our joysticks on the bottom, which control your pitch, roll, and yaw. They also have buttons. They're basically PlayStation joysticks, so you can press them down. And those like fire stages and change camera modes. And then probably the most important thing on the whole thing was the abort switch, which is probably the reason we built this in the first place. We just really kind of wanted to launch a rocket and have like a key switch, because that seemed pretty cool.
Sometimes it's the little things that keep you motivated.
Yeah, I mean, you don't get a key switch on a PlayStation controller, so that was pretty cool. And then not to forget the cool LCD, which is kind of useless in a lot of ways. It's like you can see all the information the game feeds you on the screen, but we wanted to prove that you could at least read data back from the game as well as feed it input. So we added that, and it does in fact tell you your current speed wherever you are. Right, so thus began my soldering and wiring and DIY nightmare. I'm not good at these things. I should be. I studied it for a long time, but someone who I studied with knows I was not particularly good at this stuff. So yeah, you can see there's a lot of wires, a lot of soldering. This was a very long weekend. There was much swearing. I had to redo things a lot. And then I had to actually connect it all up into that plastic casing, which we had acquired. I have not many tools, most of which I had borrowed from my dad. So I had like a drill and a file and a knife, which I could heat up and cut the plastic with, I figured out. Much later on, actually, it was very useful. Yeah, and I managed to kind of get it all in there. It's a mess. And to airport security, it looks like a bomb. I did have to bring it up from Cape Town, so it had to go into my main luggage, unfortunately. And it will be interesting to see if it works, because yeah, it was kind of thrown around a bit on the plane. It was working just now. Let's hold thumbs.
That's no guarantee of anything.
No. And yeah, then we had the final product. And as you can see on the cool LCD, it works. It speaks to the game. You can play the game. I've got an interspace with the controller exclusively. I felt pretty chuffed once I'd managed to do that, because just getting into orbit is pretty hard when you're not handicapping yourself with your JavaScript nightmare. Yeah, and that's that. Now, when we got accepted to DevConf, we thought we should add some stuff to this, just to, for extra wow and all that kind of things. And this is kind of along the lines that we were thinking. We wanted to build this cool chair that would rotate and shake when you were taking off, and something like that or that. But upon reflection, we realized it would probably end up looking a little bit more like that. Also, wouldn't be particularly easy to get up here from Cape Town, or to take back down to Cape Town. And yeah, so we just kind of gave up on that idea. But we did have another idea, enter the leap motion. So for those who know or don't know, the leap motion is this little device here. It's about the size of a stick of gum. It's got infrared cameras and LEDs. And basically, you can wave your hands over it, and it reads gestures, and you can train it to pick up all sorts of cool stuff. It also satisfied the one constraint that we had for this project. It had a JavaScript client, so we could continue with our madness and just keep on doing the JS thing.
Do what you love, everybody. That's the most important thing in life.
Yes. I'm so glad we did it in JavaScript. I still am.
Yeah.
Okay, so yeah, the leap motion, there's a bunch of hold gestures here, and you hold them above, and you can tell it to do stuff. The gesture I probably ended up using the most towards the leap motion was this one. This is from the perspective of the leap motion. I also showed it a variety of other gestures, which I can't show here. For those of you who've worked with the leap motion, it's quite an interesting thing to do. But basically, we were able to, so the one problem I had with the controller is we still had no way to control the camera in the game. You were kind of stuck with the view you had, and if you wanted to change it, you still had to go back to your mouse. So I thought, this is a good place for the leap motion. We can start controlling cameras by waving our hands around, which would be pretty cool. And we were able to do that just by very simply tracking your palm direction and palm normal, and then also your grab strength, which is just built into the JavaScript API that the leap motion provides you. So with these two things, we were able to build in a cool camera control functionality for the hell of it, really.
Pretty much.
Cool. Yeah, let's go into a demo. So we're going to quickly do a...
So while you get set up, do you want me to...
Yeah, explain why we are in this predicament.
All right, so Jake, as he mentioned, lives in Cape Town, and that's a recent development, and I live in Joburg. So for us to actually get together and practice was mostly on Zoom. And in the intervening months, I switched my primary operating system from Windows to Ubuntu, and we were thus unable to test the leap motion and the controller on my computer until this morning, at which point we found that it mostly doesn't work at all.
Yeah.
So we're just doing a bit of a hot swap back to a Windows PC.
Is it all showing there? Yeah, looking good.
Did try run it in a virtual box, but then it's quite slow. Games are not meant to be run inside of a virtual box, so there you go.
Ryan, we have a problem. Oh wait, I need to start the server. No, never mind. Don't worry.
Technical difficulties. It's part of space. Space is hard. Yes.
Okay, so I'm just starting up the client here, connecting
again,
to the board and the leap motion, all that kind of stuff. Looks like things are working. Thank goodness. All right, let's close that, give everyone a better view. Okay, so I want you all to notice I no longer have my hands on any keyboard. It's just this, and I will occasionally wave it over that thing so that we can change the camera. Let's show that now before chaos ensues. All right, so we should be in, hang on, I'm going to go to daytime quickly so we can see things a bit better because this projector's not looking great. So you can speed up time as you can just see. Okay, cool, so let's change some. Hey, it's a bit chaotic, but it kind of works. And we can go up and down. Okay, let's find a good flight view. I think that's cool. Okay, I turn off the camera control with the toggle switch on the controller just because it picks up anything it wants and it gets kind of crazy. Okay, so let's try and get this guy up. I'm not going to fly all the way up into orbit. We are running a bit short on time, but I will at least launch and you guys will see stuff. So you will notice, if you look next to the nav ball, that big blue ball, there's this thing going up and down. That's your throttle control, which I'm controlling here from this little cool potentiometer. What do we want? We want stability control on, RCS off.
Living the dream.
All right, let's go. And here we are flying. Okay, so let's see if we can get a bit closer on the view. Yeah, stop.
Look at
no,
that.
no, fuck you. Okay, cool. I'm going to start
that out later.
Here I am engaging roll, which is a cool thing to do because you can just kind of move the rocket and it doesn't change much, but it gets important later on. Do we actually want to get into orbit? Nah, whatever. Okay, so now I'm going to start pitching over. I think let's blow this one up, right?
Yeah, I think that's a good
All
idea.
right, let's drop these stupid boosters. Oh.
You might want to throttle down and then turn around.
No, throttling down is for chickens. There'll be no throttling down. Oh wait, I should probably fire that stage. Oh, that'll be good. All right. Okay, let's see if we can crash it. Doesn't want to flip over. Damn you, aerodynamics.
That's why I said throttle down.
All right. Here we go. No, we're still going up.
Try rocket back and forth. Sounds quite dirty.
Here we go. No. Come on. It's still going to be going up, even if it's pointing down. And this is kind of how motion works. But
well, you're almost at that.
Okay, yeah, we're hitting our height. Yeah, here we go. Here we go.
Now you can accelerate.
Okay. Full thrust.
More down. Add
Yes.
more down.
We must crash. I will hit the abort switch just before the end. I don't know if it'll do anything. Did we rig
this
that up?
rocket
We
has
didn't
an
rig it up.
abort.
Trust us, the abort switch is cool when we rig it up. And here we are, going full speed. We're about 7,000 meters above sea level, heading down. And we will hopefully explode. I don't see us not exploding in any... it's got to happen, right?
Yeah, you might want a physical time warp,
Okay.
which you'll have to use the keyboard for. Oh.
No, it's telling me large ship things. Hang on. Yes!
Fight against the nanny state.
Flip aboard!
Hooray!
Too late. Cool, and that's the controller in action.
Cool. So then we have a second script, which basically goes back to the point of separation of the boosters and sometimes manages to land the boosters themselves.
Turns out rocket science is quite hard.
Yeah.
This was not easy to get right. Ryan spent many hours.
Yeah, and I learned about the memory leak in here, and over time that actually makes your script not run consistently either. So you'll see we've got the output over there in the bottom, and normally when I run this script, I actually have my laptop plugged in, which I think makes it run faster. So this might not work, but it should be interesting nonetheless. So you'll see we're back to the solid booster. Now the things have separated, and it is really, really slow. So yeah, that's probably not going to work too well unless... No power cable nearby. So we'll just see how this goes.
Hey, we promised explosions. Explosions we will bring.
Yeah. So this basically follows or attempts to follow fairly closely the launch of the Falcon Heavy. For practical reasons, the flight profile is not identical because, again, the planet's a lot smaller, everything's different, and physics works in quite a vastly different way in Kerbal Space Program as to, well, not vastly different, but there are subtle differences, like wind doesn't exist in Kerbal Space Program. And you'll see we've started the boost backbone, nearly done, and if I switch to the map view, we'll see... Yeah, that's not going to make it, but we'll try a water landing. Yeah. So there's no barge there, but water's soft, and we can probably land on that. You'll see that what was happening before was our trajectory was showing that we were going to land up somewhere there, but now it's behind us, but we still have to go up a little bit. So I'm just going to time warp to help speed that up, and we should see the boosters in synchronicity. So you can see there's the other one. They try and point retrograde, which is opposite to the direction of motion. And then you'll see over here we've got the atmosphere meter, where the thicker part is over sort of there. We're in the very thin part of the atmosphere now. It looks like it's going to be a on-the-shore landing, so the beach goers should be excited. And again, this is physically time warped just to help speed up.
Show the other one. Can you see it?
Yeah. It's just turn time warp off. The other one, where is it? There we go. So it's flipped over and gone to the other side. That one looks like maybe it'll make it to land. So we'll just speed up a little bit further. And you can see down there is the 2 landing zones where they have never yet managed to actually land. But it's nice to have ambitions.
Yes.
And you'll see that at about 2,000 meters, we slow down, and the boost back starts, the legs deploy, and just before the surface of the soft ground, the things cut off.
I'm gonna go out on a limb and say that was a success. I think that was a success.
They crashed fairly close to each other, which is kind of what we were going for, right?
Yeah.
Yeah, so that just shows you, if you're running a client talking to the game, make sure that both the client has enough resources and the game itself. Otherwise, what happens is, because the physics gets applied at each step, some of those steps might go missing. Cool, so that's it for our practical demos and our talk.
Let's go to the final slides. We always forget the final slides.
The final slides, yes. Shift F5. That's a trick. Always Shift F5, not F5. Otherwise, you have to go through all your slides again. Yeah, so there you go. Shoot for the moon. So whoever wrote this has obviously never played Kerbal Space Program because the stars are way further out than the actual moon. Yes. Yeah, so hopefully this has inspired you all to go out, buy a copy of Kerbal Space Program. The expansion is out as well, so you can get going with that.
It's a free expansion. It's a cheap game as well.
Indeed. And for those of you who are interested, on Thursday, if I'm not mistaken, there's actually 5 rocket launches happening within a 24-ish hour period. There's a Long March from China, a Falcon 9 from SpaceX, and some other companies are doing some stuff.
Blue Ocean?
No, they're not launching.
Okay.
Cool. And yeah, follow us on Twitter, and you can get all the source code, plus this example, plus the ships, and a list of mods if you'd like to recreate this at home at the GitHub URLs over there. Thank you, everybody.
Cool. So,
That hand was first.
are there any questions? We had some debate as to how we were going to award this Raspberry Pi that our employer has provided, Intellect. We were thinking, is this the best question? And then we were like, maybe we should have like a moonwalkathon sort of thing.
Yeah,
anyone want to
keep in the
moonwalk?
theme.
Nah.
Anybody want to moonwalk?
At this point, if you moonwalk, you will definitely get the pie. No. Okay, questions then. Are there any?
When will production start?
Never.
So at the moment, we're looking for venture capitalists who are willing to give us vast sums of money. Until that happens, production is purely on a small scale at the moment.
This is also pretty niche. I would be surprised if we were able to sell more than 10
I'd be
of these.
surprised if we could ship them. Yeah, there was a question over there.
So how far did you get into the project before you realized that you maybe could have just used a normal controller?
Yeah, actually, good question. When we started, I had a spare gamepad, which we decided we would take apart and see if we could use the components from it to actually build this thing. So right at the beginning, we went ahead anyway.
Also, we hear you, but a normal controller doesn't have a key switch, and it doesn't have a cool throttle control slider,
Very valid
or a
point.
cool LCD. Yeah, Dito.
I'm going to have to ask you to leave if you can insist.
At Google, what's it?
Protobufs.
Google Protobufs.
Is there any delay from when you move something on the control panel to the game itself?
There is, but that's not mostly due to the Google Protobufs. It's due to the fact that now you're sending it over WebSockets as well. It's barely noticeable for the most part when you're controlling it as a human. In terms of when you're scripting, you'll notice it because sometimes your script is a little bit late and sometimes it's a little bit early.
So it's JavaScript's fault.
Probably. But you could use Edge.js to call .NET from JavaScript and then do that if you wanted to.
Since you weren't co-located, how was the experience testing it? I mean, it's a pretty hands-on project.
All of the unit tests pass and the integration tests fail today, so there's that.
That's not even a joke. We actually have unit tests for the controller as well. Like, I run Mocha tests, and like the test won't pass until I flip the switch. It's pretty cool.
Cool. You said that the server can communicate from WebSockets to TCP/IP. Are you guys using WebSockets?
Yes.
Yeah, we're using WebSockets, so you can actually, somebody has forked our library and is doing it in the browser. The problem is with the browser, which I had a much earlier prototype with, when you lose focus on that tab, it gets a low priority, so your script stops doing things.
But then wouldn't TCP/IP have less latency?
Yeah, it almost definitely would.
Yeah, but latency was never an issue during the entire time we were working on this. We never felt like, except actually today when we were we had about 30 seconds latency this morning, but it was a weird setting thing. But otherwise, we've never been like, this is too slow. It's pretty much everything is immediate as far as a human can tell.
Johnny 5 software, that's serial port to your PC, right?
Yeah,
Yeah.
USB.
Yeah. But it's emulating a serial.
Yeah.
Yeah.
To the Raspberry Pi.
It's actually an Arduino in here. We initially did, we started with a Raspberry Pi, interestingly enough. And we got it working, but mostly just for switches, because the Raspberry Pi is not so great at reading analog like stuff, and I didn't want to do the extra work to make that work. And I was like, I was just working on an Arduino, so buy one of those, just buy more electronics. So that's kind of why we went with the Arduino. And also I got the Mega in there, which has a bajillion input and output like pins. It's great. So I didn't even have to get smart with multiplexing or anything like that. So.
We're running a bit short on time
Yes.
for questions, so if you do have any further ones, I'll take one or two more, and then you can come and speak to us afterwards.
How many hours did you put into the whole project?
Which part? The building it, or the writing the core library, or writing the examples?
How did it take you to get to orbit?
I could have got to orbit like a gazillion times in the amount of energy it's taken me to write the script. But the core library, probably about 60 hours. The example, probably about 25. This Falcon Heavy one, yeah.
Yeah, and then for the controller, it's probably also about 40 or 50 hours, somewhere around there. It could have been quicker if I was better at building things and soldering and doing those kinds of things, but I'm not. So a lot of that was, I didn't point it out in the slide, but you can see where I screwed up drilling holes, and there's like a gaping hole here in the back where I thought the Arduino port would come out, but it didn't fit like that, so kind of had to
there
go
was a
around.
last question over there somewhere.
They were, and then I was like, this is a lie because there's a lot more going on than this. So I took it down. If you really want, I'll do it. I'll get it all going. No.
All right, who's getting the...
Who's getting the pie? Okay.
Probably not married.
I live with my girlfriend. It's basically married, but not really.
But I am very single, so yes.
Thanks, everybody.
Okay, wait, we're going to give a pie away.
Best question, I think it was that one.
Yeah, I think so too.
There you go. Thanks, everybody. If you want to come ask more questions, we'll be outside.
Yeah, you can also come fly the game if you want with the controller. It will work.
It might work.
It might work. It did work.